Before we talk about stable marriage, we need to talk about what a matching is. Matchings exist on bipartite graphs. A bipartite graph is a graph with two sets of vertices where no vertex from one set is connected to any other vertex in its set. It can only be connected to a vertex in the other set of vertices. A matching are sets of pairs of vertices where one vertex comes from the first set and the other vertex comes from the other set, and no vertex can be connected to more than one other vertex. A complete matching would be where every single vertex is connected to one other vertex. Now, in the stable marriage problem, you have two sets with n vertices each. One is the men and one is the women. A marriage would be any matching, and a complete marriage would be a perfect matching. Each person will rank each other vertex in the other set. So the men will rank each woman, and the women will rank each man from 1 to n. 1 being their preferred partner, n being their least preferred partner. To have a stable marriage, a complete stable marriage, there can be no pair of men and women vertices where man A and woman B prefer each other over their current partners. That creates an unstable marriage.
So this is a preference matrix for the bipartite relationship. This is an easier way of representing the man and women preferences for the other group. The women are labels on the y-axis technically, and the men are the x-axis. And how to read this graph is where the so we'll take woman 1 and man 1, where they intersect, the 1, 3. What that means is the 1 in the x-coordinate is woman 1's preference for that man. So what this means is woman 1 prefers man 1 above all other men. And then if we go across the woman 1 row, you can see that woman 1 prefers man 1, followed by man 2, then man 3, then man 4. Woman 2 prefers man 1, then man 4, then man 3, then man 2. And reading the man column is the same, except you use the y-coordinate instead. So man 1 prefers woman 4, then woman 3, then woman 1, then woman 2. And this matrix can be used to solve for the stable complete marriage.
Alright, now the question is how to use this matrix to find a stable complete marriage. And what we're going to use is an algorithm called the deferred acceptance algorithm. And the way that this works is first you take all the women who were rejected from the previous round, or in the first round that'd be all the women, and then they propose to their preferred man, the most preferred man who hasn't rejected them yet. So in their first round they would, of course, propose to all of their first choice men. Then all the men would choose from their suitors the one who he prefers the most and reject all the rest. Then this would continue on, and that's the end of one round. Then you continue on until no women are rejected. And that would be a woman optimal pairing, and a man optimal pairing would be where the men propose and the women reject and accept accordingly. And now a proof for this matrix, for this algorithm. Now let's say you have woman A and woman B, and then you also have man A and man B, and woman A is married to man A, and woman B is married to man B. Now, say the only way that this could be unstable is say woman A prefers man B over man A. The only way this could be unstable is if man B also prefers woman A over woman B. However, if woman A prefers man B over man A, then she would have had to propose to man B before she had proposed to man A. However, since she's married to man A, this means that man B must have rejected her and thus prefers woman A over, or woman B over woman A. So this would have to be stable, and this can be done for an increasing amount of up to n men and women, and so this algorithm does give you a complete stable marriage every time.
For the acceptance algorithm with the 4x4 matrix, in which the woman proposes to the man. So the women are on the left column, the women are on the rows and the men are on the columns. So in the algorithm, in each round, each rejected woman proposes to a favorite man who hasn't already rejected her. In the first round, we mark all the women as rejected. Then if possible, one man rejects his least favorite woman from those who have proposed to him. And then we continue on like this until we find a man who cannot reject any more women, and we have our complete stable marriage. So we're going to begin in the first round. We mark all the women as rejected, and therefore each woman will propose to her favorite man. So woman 1 will propose to man 1. Woman 2 will propose to also man 1. Woman 3 will propose to man 2. And woman 4 will propose to man 4. And now we will have our man 1, who has to choose among 2 women and reject his least favorite woman. So he rejects woman B, and that completes our first round. We go to our second round. A rejected woman, woman 2, chooses her favorite man, who hasn't already rejected him, and proposes to him. So woman 2 will propose to man 4. So now man 4 will have to reject woman 4. And that completes our second round. We go into our third round. A rejected woman, woman 4, will propose to her next favorite man who hasn't already rejected her, and that's man 2. So now man 2 will have to choose, and man 2 will have to reject woman 3. That completes our third round. We go to our fourth round. Woman 3 proposes to her favorite man who hasn't already rejected her. That's man 1. Now man 1 will have to choose. Man 1 will have to reject woman 1, and then that completes our fourth round. Our fifth round, woman 1 will propose to her next favorite man. That'll be man 2. Now man 2 will have to reject woman 1. That's our fifth round, and we go on to our last round. Our rejected woman, woman 1, will propose to her next favorite man, man 3, and we find that man 3 has nobody else who has proposed to her previously, so man 3 has nobody to reject. Therefore, that completes our algorithm, and which gives us our complete stable marriage pairings, which are woman 3 and man 1 married to each other, woman 4 and man 2 married to each other, woman 1 and man 3 married to each other, and woman 2 and man 4 married to each other. And this is the woman optimal complete stable marriage pairing.